Hello friends, welcome to Power Electronics lecture series. Myself Yuan. So today in this particular lecture we are going to perform a practical, that is practical number 3. We have the AC single phase AC voltage controller with the resistance as a load, okay, by using a power simulation software. Now here we'll come for this particular tab, that is we opened it as a new, okay, and you just save it. Okay, so the name is AC voltage regulator, okay, with the resistance as a load. Save it. Then for this we required two SCRs, and which are to be connected anti-parallel to each other for a phase, okay, and the neutral is connected through the source and the resistance load, and then it is connected. Instead of taking anti-parallel to SCRs, we can take a triac as well, okay, that also it is possible. So let us try to do this practical, that is AC voltage regulator. So for this we required SCR, so we'll go with the elements and power switches, and then we'll go with the thyristor. Just rotate it as usual as per our convenient. So now at this we required to design like this. So this is a forward direction, and then we just rotate it for reverse direction. So we need to make it anti-parallel, okay, and then these two have to be connected like this. So from here to here, okay, then so this and like this, you just need to connect it. And we required AC source voltage, okay, so this is a AC source voltage, and we will connect it here. And then one more, we required load as a resistance we have taken, okay, so just rotate it and put it somewhere here, okay. Then one more, we required the ammeter, okay, current probe, which is calculated current, okay, we connect here. And then we required the voltage probe, okay, so this is the voltage probe. So we'll take this and we'll rotate it, we'll connect it at the input side and at the output side as well. So instead of connecting there, we'll connect here, okay, and then join all the components, okay. So here, so this is first connection, and this is, and then this ammeter next terminal is connected to the resistance, and this the load resistance next terminal is connected back to the source, and you join it. And from here we have a voltage probe, and that also we connect like this, okay. And the remaining is, so this is the input voltage source, so this also will connect it like this, okay. And what is required, the remaining is the gating block, that is for providing the gate pulse, we require the gating block, and that is here. You select it and bring it, connect it, okay, and then you just rotate it like this and connect, okay. That means as far the connection is concerned, we completed the connection. So again, as usual, we will try to put up the values as per the ratings. So the input voltage, will mention it as a input source, okay, input source, okay, and then the voltage is 230 volt. Frequency is 50 Hertz, and if we want, we can put it the click and it will be displayed on this particular, okay. If you want, you can move it anywhere like this, okay. So there is no restriction, you can move how you want. You just click it and you just drag it and put it wherever you want, and then we click on this input voltage probe and we will give it input V input, okay, and then click it. We have, this is one more voltage probe that will give as a V naught, that is output voltage is measured, and this is the ammeter, and this is output current will be measured, and we'll give it as a I naught. After this, as usual, we will take 100 ohm resistance, and this is the load resistance, okay, and so this is 100 ohm, okay. Then okay, the next is we need to set up the values and names of the thyristor. So this is the thyristor, that is T1, and this is the thyristor, we'll take it as a T2, and so we have these two, that is gating blocks. In the gating blocks, we need to provide the switching points, okay, and the frequency which we are operating, that is 50 Hertz, and this is the G. Click it on the boxes which we want to observe, and then next is click on this second gating block and name it, that is G2, and the frequency which we are providing, that is T Hertz, and so here you can see here what we are giving. So we are giving here, that is 180, okay, 180 to 360, okay, 360, then we put it, and here what we have given, we have given 0 to 180, but we will give it here as a 30 degree, okay. We can observe here one thyristor, that is T1, we have given a gate signal, gate pulse, that is the firing angle which is given for T1, that is 0 to 30 degree. Okay, from 30 degree to 180 degree it will conduct. Okay, from 0 to 30 degree it will not conduct. And then we come for this T2, that is thyristor 2. Here the firing angle has been given 0 because the conduction period which we have given, it is from 180 to 360. So here we need to change it. It became 3006, so 360. Okay, so we need to take care of this. So here we have given a 30 degree as a firing angle for this T1, and for T2 we have not given any firing angle. That means the conduction period is from 180 to 360 degree, and here the conduction period is 30 degree to 180 degree. Then as usual we require a simulation control. Okay, we'll click it and just click it, put it total time, that is 0.04. okay, then after this I think we have completed the AC voltage regulator with the resistive as a load. We have completed all the connections. Now we need to perform this with the help of by running this particular circuit. So run PSIM simulation. I think it was taken previously, which we have calculated. So go to the simulate, click on, and then run simulation. Okay, so variables are available, that is output current, input voltage, output voltage. Okay, so initially I will take it as a input voltage and I will click it, and it will come at a variable for display. So click on OK, and it shows the input supply waveform. Okay, so that is it is 230 volt supply. Okay, then click on one screen, add one screen, then we click on the voltage, output voltage, and add it, and it has been added to the variables for display. Now thing is to observe the during positive half cycle and during negative half cycle. Okay, so click it OK. Okay, so then I will make it little bit more, so thereby you can have the clear idea. Okay, how much the firing have given? We have given the firing angle, that is 30 degree. Okay, for thyristor 1. Okay, so during positive half cycle, you can see from here to here it is positive half cycle. During positive half cycle only we have given for thyristor 1 as a 30 degree as a firing angle. Okay, it will up to 30 degree it is 0, and after 30 degree the output will be appearing. But in the during negative half cycle, during this negative half cycle, so the thyristor T2 will be conducting. So that during that we have not given any gate firing angle to the thyristor 2, because we have given a conduction angle that is from 180 to 360 degree. So therefore there is no gate pulse has been given to this particular thyristor 2. Now At the same time we'll take the current as well, output current, so it is also the same thing as like the voltage. Okay, but the thing is that the current which we will get here around 2.1 2.2. okay, then we will try to understand little bit more about this. Okay, so instead of providing this as a 30 degree, we will provide this as a 0 firing angle. So if we want to provide 0, we need to put it 0 because there is no firing angle, and then this is also not provided any firing angle, and then we'll try to perform this. So let us see what will be the output. Okay, and you just do it Control S, so thereby it will save the data which we have given the values, and go on the simulate, click run the simulation. Again there are 3 variables we get, and add it and the second one you just put it, that is output voltage, add it and you will get it. Then see, and one more, that is output current, add it and get it. So you can see what the change is there. There is nothing change because we have not given any firing pulse to the SCR1 and SCR2. Okay, for both the conduction period is given for SCR1 is from 0 to 180, and for SCR2 we have given conduction period is 180 to 360. So thereby there is no spike has came. Okay, so whatever the input voltage is there, so that is following this. Okay, and then we'll try to do it in different way. So take this, and for this we will provide some, say it is 90 degree. Okay, 90 degree is nothing but 180 plus 90. Okay, it is 270. Okay, so we'll put it 270. If we put it 270, the firing angle will be 90 degree. Okay, so we'll see what happens if the firing angle is 90 degree. Okay, so we have seen by giving the firing angle as 30 degree, so we will try to find out what will happen if the firing angle is 90 degree. Okay, so we have given the values and make it save. Okay, otherwise you can go on this save button and you can put it, click on the save button, and then go to the simulate and run the simulation. So here the values, okay, which we got, you can see during positive half cycle. Okay, during positive half cycle the complete cycle has been given. Okay, but during negative half cycle, that is for thyristor 2, we have given a 90 degree firing angle. So that means up to 90 degree, okay, that will be 0 and it will be like this. Okay, and again from positive, during positive half cycle, the cycle that is, there is no delay in that particular positive half cycle. Okay, so likewise, so the same thing will be followed for the current. Okay, because the resistance, if the load is resistance, the current and the voltage both are in phase. Okay, so therefore it is showing like this. Okay, so So if you take a more, that is firing angle more than 100, that is more than 90 degree, so what happens? So it will again gives the delay and then it will continue. Okay, so this is about AC voltage regulator by using the load as a resistance. Okay, so in this only we will try to understand, okay, so how this particular voltage has been measured and current has been measured. Okay, so all the parameters we have measured, that is the input voltage, output voltage and the output current. Okay, based on doing the, by giving the firing angle or by giving the conduction angle. Okay, so you can call it as a conduction angle or you can call it as by giving the firing angle. Okay, it is left to you. So this is about AC voltage regulator with the resistance as a load. Okay, thank you very much.